Welcome and thank you for stopping by CryptoCoinMindSet. This video is from the Free State Bitcoin Digital Asset Conference that took place in New Hampshire on October 12th, 2025. And in this video, we're going to listen to a chat between Steve Kokinos, the founder of Sonic Boom Ventures, and Derek Yu, founder of Moonsong Labs. They'll be discussing how Bitcoin mining can help the existing energy infrastructure in the United States and AI and its power consumption needs. So let's get into this video and listen to the chat.
All right. Hi everyone, I'm Steve.
Hi, and I'm Derek Yu.
And just by way of background here, Derek and I have worked together for 30 years.
Quite some time, although we don't work in the same company right now, but we have some shared history.
Yeah, true for sure.
I'm happy to kind of kick things off here. So Steve reached out to me and asked me to join him here. I jumped on the opportunity to talk about some interesting topics. We, as themes, we'll explore a little bit about, Steve, one of your latest ventures that's in the energy space. So talking about infrastructure, energy, how that relates to Bitcoin, and some other themes that are related to like energy and infrastructure.
Have we ever actually been on stage together?
I think so. It's been a while, but probably at some point in the past. So just a little quick background, then I'll hand it to Steve. So for myself, been spending almost all my career, about 30 years, building software. Software infrastructure is really my specialty. Since 2019, I've been building like in the blockchain space. There, focusing on kind of developer infrastructure. These days, a lot of AI and AI agent infrastructure. That's been my area of focus. Steve, why don't you go ahead and kind of give us a little bit about your background and
Derek's a very modest guy. We both have been building infrastructure since we were 20. We're much older now. From the early days of the infrastructure, from the early days of the internet. And I think that if I took kind of one theme over that period is that a lot of new technologies are basically kind of big misunderstood situations. And I think that's really the case in Bitcoin and crypto as well. But it's certainly been an adventure. After starting and selling one of the first internet kind of web hosting data center businesses, we started one of the first cloud computing kind of data center automation businesses, build communications infrastructure, and I guess I've been doing the crypto thing for a little bit longer than you, but probably about 8 years. We both launched Layer 1 blockchains, both are involved in Bitcoin mining and energy, and talk through a little bit about how we think all those things interrelate. But it's I think a fascinating space that has a lot of different ways that people need to think about it. But I think one of the fundamental questions I hear a lot is just sort of understanding how Bitcoin works and how all the different kind of components play together. So we thought maybe we can help give a little bit better understanding of that.
Well, I know lately you've been kind of moving, let's say, down the stack from software into this more physical and energy infrastructure layer. One of the projects that you've been working on is called Hydromine. Maybe tell us, just give us a quick snapshot of what that is as an entry point to the discussion.
Yeah, well, I guess before I get into that, I don't know how many of you remember Celsius back during the crypto fiasco of 2021, maybe? So around FTX time. I was part of a group that won the bid to take Celsius out of bankruptcy. Mike Arrington, who was the founder of TechCrunch, called me and said he was assembling a group of friends to give it a whirl. None of us knew anything about bankruptcy, which I would largely, I apologize for any bankruptcy specialists here, but I would quantify as mostly villainy. We thought there was an opportunity to kind of take some of those assets and really do something that might be valuable to the creditors. A lot of people lost a lot of money and were hurt as part of that. Unfortunately, the SEC blocked our bid to take that company public at the last minute, even though the judges asked the SEC every single hearing to tell them if they planned to do that, so that they wouldn't waste everyone's time and money. But what I learned was that the a couple things. One, Celsius has spent about $600 million on Bitcoin mining gear for reasons that were not entirely rational, but was certainly a lot of geared boxes. They also had billions and other assets. But what I really learned as part of that is, Bitcoin isn't just a consumer of energy, which is I think that the narrative that you hear in the news. Bitcoin is really supportive of the energy grid and energy production because in a lot of cases there are sort of deep inefficiencies in the way energy is produced, and Bitcoin really can act like a battery by consuming power that otherwise would just go to waste, especially in places like natural gas production. A considerable amount of gas just gets flared off every day and just literally lit on fire. By being able to use that gas to produce energy and mine Bitcoin, now you're able to do that. So I think this is one of the lessons that I learned as part of my brief and what will be only bankruptcy proceeding is that the energy markets are pretty inefficient, and the Bitcoin really does represent a way of taking advantage of that.
That makes sense. And in particular, I guess, in this energy sector, you've been becoming expert in hydroelectric, right? In that like sector. So tell us a little bit. More expert than I am. Tell us a little bit about kind of hydromine, what it is, to just give people context as we dig into that part of the conversation.
So my simple conclusion around Bitcoin mining was that looking for these sort of dislocations in energy was probably the best way to approach that problem, and that ultimately if you could have cheaper energy than anybody else, that you could sort of mine at any dollar value of Bitcoin and not really care. And so started looking into this. What I found was been like a fascinating odyssey. Partnered with a couple of folks who've been in the hydroelectric business for a long time, and what we learned was that during the Biden administration, and I have a whole litany of problems that were caused by the Biden administration's energy policy. But the Biden administration sort of took all subsidies away from hydroelectric generation, and then also reduced the rate, or reduced the federally mandated rate that power companies would have to buy hydroelectric power for, with the goal, and I guess they achieved a good chunk of it, of bankrupting most of the subscale hydroelectric facilities. And so there's a situation now where a lot of facilities aren't actively producing power. The idea of taking those dams out, given that many of the facilities are in rural communities, is absolutely ludicrous. And you may have a town with 500 people in it that would get a bill for $20 million to remove a dam. And also point out that a lot of people have lake houses that exist because of the lakes that were created by those dams, and nobody wants to rip those out either. So it's a complicated situation, and left unmanaged also presents real public risk to doing that. But I think that's what we found as kind of the state. And the other is, when facilities go bankrupt, they lose their license to sell power. And so what we've looked at are, where are there opportunities to take over power generation facilities. You may not be able to sell the power, but you can consume it on site by mining Bitcoin. And there's a lot of sort of complicated details that we've learned. It's been more of an adventure than we thought, but certainly interesting.
Yeah, so maybe talk a little bit more about that, about how Bitcoin changes the economics, or changes how you could run like an energy hydro plant like you're describing.
Well, there's sort of two parts. First, many dams are owned by the municipality, not by a power company, but the powerhouse, the actual power generation facility, typically is like further downriver from where the dam is, and water is kind of piped into it, and those are run by private companies more typically. But the issue is, if you stop selling power to the utility, you then have to apply to restart selling power to the utility. And while power generation is somewhat decentralized, the distribution network is basically a monopoly in almost every place that you go, and so you're sort of beholden to one place. And it's 2 to 3 years minimum to be able to start selling power on something that's been inactive. And so, I think what you have are a lot of facilities where people just walk away, and then they fall into disrepair, and you're in real risk of things like oil shooting into a lake or a river, and nobody really wants that. And so I think where Bitcoin changes that is by being able to consume power on site. Now it's creating incentive to refurbish a lot of the distressed kind of assets and generate profit out of it over time. And then ultimately we think that in some cases Bitcoin mining will be permanent. In some cases there'll be an opportunity down the road to resell those power into local communities, which I think can be very helpful, especially in rural communities. One of the things that's a problem is power reliability is often not a result of like lines being down or there not being enough power. There just isn't enough baseload. Not enough people are using enough power to just keep the lines charged all the time. So one of the things hydro facilities do is provide baseload in a region that may not have a lot of power use by energizing the lines, and it makes things much more reliable. And so there is, there's a lot of value in kind of multiple directions there.
So in looking at these questions, you mentioned before the example of a natural gas facility where they're flaring off gas. There is a similar concept in with the hydro plant, right? Curtailment, I think it's called, right? So does Bitcoin help with that, or how what's the situation?
Well, I think
with that.
I think the best example of that is what's gone on in especially West Texas. The federal government, again, another amazing example I'm going to give you here. Put out enormous subsidies for people to build wind and solar generation capacity. In Texas, it's mostly wind. What they didn't do as part of those subsidies were pay to connect it to the grid. And so in Texas, there were enormous wind farms that were built, paid for with federal money, and then not connected to the grid. So basically the people who built it got their money and their profit for doing that and sort of walked away. And some of this stuff just like really defies belief, but it's true. And so what ended up happening was Bitcoin mining groups there, and many of the big, Marathon, Riot, US Bitcoin are all kind of in that area, went in, both installed their Bitcoin gear, but also connected them to the grid. And what happens now is in the summer months, if I take a step back, virtually all of these companies now sell power hedges back to the power company. And what happens is in the summer months in Texas, when it's hot, they don't have enough power for air conditioning, they will start buying power from the mining companies. And what the mining companies do is they have curtailment software built in to their farms. When when the utility wants to buy their power, it may be that they're mining at 6 or 7 cents a kilowatt hour. The power company might pay 40 cents a kilowatt hour for a week or two. So over the July and August months, if you take a look at the Bitcoin mining performance or the financial performance of the Bitcoin mining companies, it tends to be much, much higher. And the reason is they shut their machines off, sell the power to the grid, and then use the resulting money to buy Bitcoin. And so it's a little bit of a thing that you wouldn't guess. But what they've really done now is effectively increase the generation and connectivity to the grid. They consume it when it's not needed, but when it is needed, it still makes its way to the grid, so that these people can get the power they need. So I think there are many, many examples of this kind of like symbiotic relationship between Bitcoin mining and power generation and distribution.
You mentioned a couple times, obviously wind, solar, hydro are often mentioned together. Just maybe give us your audience some sense here of where does hydro win, when used which, do you see any trends moving forward across those renewables and or other energy sources?
Well, hydro always wins over those, the others. The problem also with wind and solar is whatever the stated megawatt capacity of a given plant, they're typically only producing at about, to be generous, 30% of whatever that stated amount is, because you're relying on sun and wind. Even offshore turbines in the ocean, they do a little bit better, but not, it's not 100%. Hydro typically can run with something very close to that, provided there's water flowing. There are places where it doesn't flow 365 365 days a year. I think in most of those locations, often they take kind of July and August off and do maintenance. But I think the rest of the year it's a much more reliable source, of power generation. So I think as far as renewables, probably nuclear and hydro are probably the two most consistent. I realize nuclear is not exactly renewable, but it's not. But it is clean energy.
It's not fossil fuels, Let's switch gears a little bit. So it's hard not these days to talk about energy without at the same time mentioning AI, right? AI being a big demand driver for energy. You see a lot of new energy kind of facilities being built out with the idea that they're going to power AI workloads. So tell us a little bit about that, right? In the context of, okay, I maybe have some Bitcoin mining farm. What is it? Do people then create like a hybrid scenario? Are there different economics at work when trying to employ that energy for AI use cases? What are you seeing, and how do people think about that?
Well, a couple of things come to mind here. One is, if you think about not just Bitcoin but crypto in general, I think the idea of programmable money is very interesting. And if you look at the amount of financial innovation that we've seen over the past 5 to 10 years with crypto, it's vastly more than we saw in the 100 years before. So I think these programmable instruments are sort of a new way of thinking about finance. And I just as to how that answers part of your question, I think as we start to see AI agents doing more AI, we're going to want to let our AI agents spend money. I think it's very hard for AI to go open a bank account, at Bank of America, but it'd be a lot easier for agents to have wallets and be able to distribute money that way. And so I think that what we're starting to see is an intersection of those two worlds. I also think if you look at kind of the spectrum of infrastructure, the web infrastructure that we built a long time ago took very limited power. Bitcoin mining is probably the most power intensive, but AI sits somewhere in the middle, so that data centers and the power profile of traditional data centers aren't suitable for AI workloads, which is why people are rushing to generate more energy and build more data centers. And I think that those two have a lot in common. However, if you look at a megawatt of Bitcoin mining, let's say there's probably a couple $100,000 of capital expense for that if you were using older gear, maybe about $1 million if you're using newer gear. AI is probably about 10 million per megawatt. So it's much more capital intensive, but obviously it requires a very similar amount of power to Bitcoin.
Yeah, that's interesting. It's a 10x different in capital requirements, I think Bitcoin mining, it sounds like, is really a great baseline for enabling and opening up these new opportunities. I want to pull on a thread that you mentioned. You're kind of moving up the stack to areas that where I spend a lot of my time. I totally agree with you on that. We're working on many AI agent implementations, right? So these are happening everywhere, and I'm sure for many of you in the audience, you're using these AI tools yourself on a day-to-day basis as well. But I would say that I also have been thinking about these payment scenarios you talked about, right? So if you're going to have these agents out there, maybe representing yourself or your company, maybe autonomously, right? That maybe they could be autonomous agents. They need to be able to pay each other. I'm reminded you were telling a story about these early internet infrastructures you worked on. I do think there is something that kind of worries me there, right? Where those early days of the internet infrastructure, it was very open, very protocol-based, very Bitcoin-like, right? It's like, hey, here's a system, there's open rules, anyone can participate. That, as we all know, dramatically changed over time, right? And let's say the aughts, with the rise of social media and other networks where you have these small number of proprietary companies. I do think we're facing a similar moment right now with AI, where there's a few very powerful companies that could that could really control a lot of that future commerce, a lot of that future activity. So I'm just curious, just get your take on where and how do open standards, open protocols fit into this world? Are there different ways you have of looking at the development of these AI agents, and how what the paths forward could look like?
Well, first of all, don't let your kids become computer programmers. I'll answer your
Lovable users or something, right? Instead.
Well, computer scientists, yes, but coding as a discipline is, for sure.
Yep.
Just to give a quick anecdote, a good friend of mine runs a pretty big software development shop, and they've been investing for several years in AI tools. They're reducing the size of their workforce. Now, you still need very senior people who can design the tooling and ask the right questions, but they have their situation to a place where they have a meeting with the customer, the meeting gets recorded, transcribed by AI, that transcription is fed into their systems, and they can spit out a prototype of what the customer was asking for within a few hours. That was something that would have taken a long time. So I think, I think your question is a good one here on what the value of decentralized systems and openness is. I think one of the real risks that we face in kind of an AI world is that people don't know whether the answer they're getting is true or not, or what generated it. And so I think one of the if you really think about one of the highest values of decentralized systems, it's creating trust. I think that decentralized trust is something that Bitcoin has proven is very valuable. I think that's something that we're going to need more of, but probably need more of in slightly different settings to understand that transactions are valid, that the answers we're getting from AI are valid. And I think that decentralized open source systems give people an opportunity to understand what the underpinnings of that are, and also know that the technology itself hasn't been hasn't been hijacked. I was just listening to a interview with Pavel Durov, the founder of Telegram, and he talks about how they're the only people that have both the entire Telegram infrastructure open sourced, and that all their mobile applications are also reproducible, so that you can go and rebuild it and prove that the same version that's on your phone is the same version that's built. So I think more and more using decentralized systems to prove and guarantee trust, I think, is going to be incredibly important in an AI world. So I think those things go sort of hand in hand.
Yeah, I 100% agree that right now what we're seeing is, at least on my side, AI agents, other things are largely being employed inside of companies, so they're already within the same trust boundary, right? You can have all the AI agents talk to the same database, share information, it's all within the same trust domain. That changes quite a bit if you want to have your AI agent negotiate or interact with someone else's, right? You're not going to have the same kind of trust assumptions there. And that's where, just as with Bitcoin, having this kind of trust minimized way to interact with other entities is quite important. So I agree with that. I also just want to go back to your comments on the coding. Obviously, that's the line of work I'm in. We are seeing I wouldn't be so quick to say not like to study coding, but it's definitely changing rapidly, right? I mean, I think this act of actually coding, that's something that is going to become rarer and rarer. And it's more about how do you direct these coding agents to do what you want.
Right.
We're seeing even some difficulty here, right? Because there's some people who got into coding for the love of it. They love the act of coding. I think it's difficult for those folks where, you may love that craft, but there's this machine that can do it at 10 times the speed. So maybe that still remains a kind of an artisanal thing, but probably not for the mainstream functions. You need to get to know how to direct these agents to do your bidding, basically.
Well, one thing maybe might be interesting for people to hear. I do believe what I said about coding, but I also believe that computer science is always in demand, and probably more heavily so. I think one of the things we've seen is that these large language models, everyone's decided they're the cure for everything. I think there's also going to be many more smaller language models that are more specialized, and there's a huge kind of space that is going to start to be more prevalent there. Maybe just talk about how you see that evolving over time.
I think that it goes back to some of the concerns I raised earlier, right? Is there a world where there's just 3 companies with the giant mega models, or are there many smaller companies, many smaller, more specialized models? The second is a much more attractive proposition to me. I tend to think about historical analogies. So there was once a time, this is actually a little bit before my time, believe it or not, when people said the same with computers, right? So like, what kind of computers will it be? Oh, they're so expensive, they're so, they're so difficult to maintain. There's only going to be like 5, 10 computers in the world, right? And like, there's only going to be these, large computers that process all the world's information. Well, guess what? That's not the way things turned out, right? You had first MIDI computers, then PCs, then there was this kind of democratization of like the technology. So that's more the direction I think things will move in. There'll always be room for these big players, of course, that have data advantages. But we're seeing like a lot of, for example, open source LLMs and models are getting quite capable. So if you have some knowledge and data that you can put around that, you can really create specialized models that are quite effective.
Well, I mean, I think if you look at Bitcoin couldn't really exist without the internet, and I think AI can't really exist without Bitcoin and other blockchains. And so I think that's we sort of have this kind of iterative piece where I think everyone tries to liken kind of the next wave of tech to the one before it. I think they're all a little bit maybe interrelated more than it's realized.
It's the whole it rhymes, right? History like rhymes.
Yeah. Maybe I don't know. Should we just?
I think we're.
Anyone has any questions?
Yeah, I don't know if anyone has a question. I think we might be up on time, so feel free if anyone has any questions for us.
Yeah, one question. What do you think about centralization or decentralization with open weight models? I don't know if it's more a parallel to open source software, but do you see things consolidating to closed weight models being more capable and having them get too far ahead of the open weight models? Just what are your thoughts on that?
I'll take this one. So, there has historically been and continues to be a gap in performance between proprietary models and open source or open weights models. And just let me step back. So just to explain, frequently with software, people spoke previously about like open source, right? So is the source code available? Is it not available? When it comes to these models, there's this concept of weights also. So like you can be open source but not reveal the weights. This is a trick some people play where it's kind of half making it like public, right, and not fully. And so really you want, like, if you want true like openness and transparency, you want the source code to be public as well as the weights of the model to be public. That gap is not growing. So like I would say that the open source and open weights models are keeping up with the leaders that have the proprietary models. So I expect that trend to continue. I mean, the big thing was, you had like these Chinese like open source models come out like earlier this year that, was a bit of a shot across the bow for, these big companies to say, hey, like, look, with the right like ingenuity, without as much capital as we have, people are still able to make like highly performant systems. So I expect that to continue. And of course, those open source and open weights models are, the right, like a good infrastructure and tools for folks to use that are pursuing specialized like use cases, being able to, let's say, manifest that vision I was talking about before about a more decentralized world of AI.
I hope you found that video educational. Don't forget, links to the Free State Bitcoin Digital Asset Conference, its sponsors, and the people you saw on this video are in the description, so go ahead and check them out. And head over here for the entire playlist from the Free State Bitcoin Digital Asset Conference, and I will see you there.